every now and then a section comes along which is really and truly difficult. This is one of those sections. 8.5 Compound Trigonometry Applications. So we talked last time that applications basically meant word problems. You know, trigonometry is the study of triangles. Basically compound is referring to the fact that you're going to have to use multiple triangles in each one of these questions. The hardest part of these questions is actually figuring out what are they talking about. You're going to have to draw some pictures, and sometimes it's very difficult to figure out what you should be drawing. So I'll do 3 of them with you in the video here, but these are difficult. We'll have to work together to get some of these in class, I think. Okay, from the top of a 200-meter high building, the angle of depression to the bottom of a second building is 20 degrees. And from that same point, like from that 200-meter high point, the angle of elevation to the top of the second building is 10 degrees. Calculate the height of the second building. So it's a little bit confusing, as most of them are. But let's say this is one building. This is the distance between them, and here's the other building. Now the first thing you have to figure out is which building's higher. And since from the top of this 200-meter building there's an angle of depression and also an angle of elevation, this must be the 200-meter building. This must be 200 meters right here. And then there's an angle of elevation and an angle of depression. Remember, for both of those things, angle of elevation and depression, you measure it from the horizontal. So you need to draw a horizontal in there. And it says the angle of depression, it says first. So the angle of depression, remember, is not here. It has to be between this line and the horizontal. So the angle of depression is right here, and it is 20 degrees. And from the same point, from this point, the angle of elevation, so up here, is 10 degrees. And what we have to do is we have to figure out the height of the second building. We have to figure out this whole distance right here. Well, you already know part of it. How far is the distance from here to the bottom? It's exactly the same as from here to the bottom, so this is 200. So basically, that's from here to here. So basically what you need to figure out is from here to here. Let's call that x. Then we'll add on the 200 and we'll be done. Now, how are we going to do that? If you look up at this top triangle, we have an angle and we're interested in one side, but we need to know another side. We don't know this side and we don't know the red side. But this red side here is shared with this other triangle on the bottom. This shared side, when you find a shared side in the two triangles, that's almost always be the side you're going to have to figure out. So if you look at this bottom triangle, that is this triangle down here, do you see you know an angle? You know one side here, and we could then use that to figure out the unknown side, this red side right there. So just to hopefully make it a little bit clearer, I'll redraw this bottom triangle. And what we know in that triangle is, well, we know this is a right angle. That's great news. It's a right angle. This is 20 degrees. This is 200. And what we'd like to know is this side up here. Let's call it y, I suppose. Okay, so this is our y right there. Okay, how can we do that? We look from the angle we know, which is 20 degrees. The sides we're interested in are opposite and adjacent. Which one's that? That's tan. So tan 20 equals opposite, which is 200, over adjacent, which is y. Oh, variables on the bottom, you got to switch these two spots. So y equals 200 divided by tan 20. Get your calculator and do 200 divided by tan 20. You might need to put the tan 20 in brackets, but anyway, try that out and you should get 549.5. So you now know that this amount right here on the red line is 549, it's a pretty bad 4.5. Okay, let's draw that top triangle. In that top triangle, if this is a right angle, this is also a right angle, so that's good. We know this angle here, it is 10 degrees. You now know the bottom, it's 549.5. And what you want to know is this distance right here. Okay, we can do this. Again, we look from this angle, what do we have? Opposite we're interested in, and we know adjacent. It's tan again. So tan 10 equals opposite, which is x, over adjacent, which is 549.5. Oh, variables on the top, that makes it a little bit easier. 1 times x is x, and then you just have to multiply 549.5 times tan 10. And if you do that, 549 times tan 10 is 96.9. So you now know that this x amount right here is 96.9. How do we get the total amount? You need to figure out how much this total distance is right there. No problem. If from here to here is 200, and from here to here is 96.9, the total height is 200 plus 96.9. It's 296.9 meters. Finished. Tricky, eh? Guess what? They get tougher. The lengths of side AB and side BC of a scalene triangle, ABC, are 12 centimeters and 8 centimeters respectively. The size of angle C is 59 degrees. Find the length of side AC. Do you remember what scalene means? I don't know if we've talked about this recently. We've talked about equilateral, where all the sides are the same. We've talked about isosceles, where two of the sides are the same. And in scalene, all sides are different. No sides are the same length. No sides same length. So let's draw this triangle. Now, of course, we don't know exactly what it looks like, but doesn't matter. It's not a right triangle. Doesn't say it is anyway. It might turn out to be, but I don't think so. The lengths of side A, so it's triangle ABC. So let's just put ABC. Doesn't really matter if you put ABC or ABC or whatever. I'll just put it in this way. The lengths of side AB and BC are 12 and 8 respectively. You know what that means respectively? It means the order that they're listed, AB and BC, is the order that the numbers are given. So AB is 12 and BC is 8. And what we need, oh, and we also know angle C is 59 degrees. And what we need to do is we need to find the length of AC. We need this entire distance, this entire length down here, all of that. How are we going to do that? I don't see any right triangle in here, and this chapter is all based on right triangles. Well, you need to make a right triangle. And the way to do that, I would say, is to do this. Turn it into two triangles. Instead of having the one triangle, turn it into two triangles. And if you draw this straight down, what kind of triangles do you have? You have right triangles. So this is a good step. All right, let's think about this for a second. What do we need? Well, we need, if we break it into two triangles, we need this piece down here. We also need this piece down here. Then we'll add them together. Well, if you look at this first triangle, and maybe I'll draw it right now, on the right here, you're ready to get that piece down there. This is a right triangle, it's 59 degrees, and this is 8 here, and you want to know that. Hey, we can do that. If we look from the 59 degrees, what are the sides we're interested in? Adjacent and hypotenuse. That's cosine. So cosine of 59 degrees equals adjacent, which is x, over 8. 1 times x is x. 8 times cos 59 will give us our answer. And 8 times cosine 59 equals 4.12. So we now know that this amount right here is 4.12. Great. Now all we have to do is get this amount. This amount down here. So let's draw that triangle. I'll draw it over here. What do we know in that triangle? Well, we know it's a right angle. Great. We know we want to know this amount down here. Let's call it y. We know this is 12. And what else do we know? Nothing. Well, we need to know something else. We either need to know this side here, or we need to know one of these angles. You can't figure out either of these angles right now, but you could figure out this side. How do you do that? Go back to this drawing. Can you figure out this side, right? This side here in this drawing is exactly the same as this side here, right? It's the same as this here. All those are the same thing. So let's look at this triangle again and figure out how do we get that distance. Let's call it h for height. You can call it whatever you want, but I'll call it h for height. So look from the 59, we're using the h and the 8. You could also use the 4.12 here if you want, but I'll just use what we have, which is h and 8. Look from the 59 degrees and we have opposite. We're interested in getting that side. That's the opposite side. And we know the hypotenuse here. Opposite and hypotenuse is sine. So we're going to do sine 59 equals opposite, which is h, over 8. Cross multiply, 1 times h is h. 8 times sine 59 degrees. So h equals 8 times sine 59 is 6.86. You now know that this is 6.86. You now know that this here is 6.86. You now know in this triangle that this is 6.86. We need to know y here. Okay, you could do it by first of all finding one of these two angles and then using like sine or cosine or tan or something like that. But you could also do it in one step right now, right? This is a right angled triangle where you know two of the sides. What can you use? Pythagorean theorem. It's good to remember the Pythagorean theorem. You'll use it quite often in these trigonometric problems. So you know the hypotenuse. So you're going to square both of these. You're going to add them or subtract them? Subtract them. You already know the biggest side. You already know the hypotenuse. So 12 squared minus 6.86 squared equals y squared. 12 squared is 144. 6.86 squared is 47.06. That's equal to y squared. So y squared is equal to, if we subtract those, you get 96.9. Got to take the square root of that. And the square root of 96.9 is 9.85. So this amount right here, at long last, we figured out is 9.85. If you want to get the total distance for AC, AC is equal to 9.85 plus the 4.12. 9.85 plus 4.12 is 13.97. Does it say centimeters or anything? Yeah, centimeters. So 13.97 centimeters. Alright, that's 2 done, 1 to go. Alright, before I do this question, I need to introduce you to this idea of a bearing. A bearing is a direction of travel. It's like the direction you're moving in. And the way we state it is it's the number of degrees east or west of north or south. Okay, so it has to be an angle which is less than 90 degrees. What do we call an angle that's less than 90 degrees? We call it acute. So it's going to be an acute angle, either east or west, and then either north or south. So it could look something like this. South 40 degrees west. Now what that actually means is 40 degrees west of south. Okay, it's like south. Okay, oh, by the way, do you know your directions here? Never eat soggy wieners, right? Or never eat shredded wheat, some people say. So south, well, south is this direction, but then we want 40 degrees west of that. West is this direction, so that if we want 40 degrees west of that, that means we'd be going 40 degrees west in the west direction from the south. That makes sense? It's a hard thing to explain. Hopefully you're getting what I'm talking about. Let's try another one. If it was north 30 degrees east, that means 30 degrees east of north. Well, north is straight up, but we're not going straight up. We're going 30 degrees east of that. Well, 30 degrees east is in this direction, so it would be 30 degrees here. This is the way you're going, right? In this one, you are moving in this direction. In this one, you're moving in this direction. It's the direction you're moving in. Okay, one more. North, 45 degrees west. So that means 45 degrees west of north. By the way, in the book and stuff, it's not going to give you this part in brackets. It's just going to say north 45 degrees west, and you got to figure out what that means. Okay, well, north is up, but we're not going north. We're going 45 degrees west of that. West is over this direction. 45 degrees is like halfway, so it's like this. This is 45 degrees right here. So the direction you're moving is this. That's the direction you'd be moving. Okay, kind of tricky and bizarre, but that's how it is. Alright, a ship leaves at noon. So let's say it started here and it leaves at noon and heads due west. Well, that's this direction. And it goes at 20 knots per hour. A knot's nautical mile. Don't worry about that. Anyway, it's going 20 knots per hour. At 2 p.m. it changes course. Okay, so it's left at noon, it's going 20 knots per hour, and at 2 p.m. So how long did it travel? If it left at noon and now it's at 2, that's 2 hours, and every hour it went 20 knots. So the first thing you have to do is you have to figure out that 20 times 2 is 40 knots. This boat has traveled 40 knots in this direction. Now it changes course. It's going north 54 degrees west. So what you want to do, it got to this point right here, right? And then it's changing its direction. You want to kind of superimpose one of these northeast southwest things right there. So I will put a yellow so it doesn't show up very well, because we don't want this to really show up very well. I will put one of those right there. And what it says is that the boat is now moving north 54 degrees west. Well, north would be straight up, but it's not going north, it's going 54 degrees west of that. So it's going out in this direction, where this angle here, from here to the yellow, is 54 degrees. Okay, hopefully that makes sense. If not, take a look back up here at the bearing. What we need to do, maybe I'll take that arrow off actually, I think that might just confuse things. So take the arrow off. It traveled for 1 hour in this direction, the same speed. We have to assume it was the same speed. It doesn't say that, but let's assume. So it now finishes at 3. It traveled from 2 to 3 in this direction. So how far did it travel? Well, it was going 20 knots an hour. It went 20. And what we now want to know is, how far is it, the boat, because the boat's now here, right? How far is the boat from where it started? So you need to know this distance right here. And you also need to know the bearing. Well, to get the bearing, the first thing we have to do is we have to figure out this angle right here. I'll call it theta. Those are 2 things you're going to have to learn, or figure out. Again, there's no right angle here. Yikes, how are we going to do this? Well, you need to make a right angle triangle again. One way you could do it is you could put it here. You could draw a line straight up and down. That'll look good on this triangle because it'll be, like if I put the line right here. Let me just draw that. If I draw that, looks good here, we got a right triangle, fantastic. Doesn't look so good in this little piece because there's no right triangle there. So I would suggest that's not the best way to do it. The best way to do it is to make the whole thing one big right triangle, because now you have 2 triangles. You have the big triangle here, which is a right triangle. You also have this smaller triangle, which is also a right triangle. This is going to be useful. Let's draw the small triangle first and see what we know. So I'm drawing this small triangle here, and what I have is, I have a right angle. I know that this hypotenuse here is 20, and what else? That's it. Although we can figure out this angle right here. How come? Because this angle from here, how am I going to show this? This angle from here to the yellow right there is 90 degrees. That's a 90-degree angle. So if that's 90 degrees, and this is 54 up here, how much must this be right here? That angle there must be 90 minus 54 degrees. And so if you do that, you'll find that this angle in here is 36 degrees. Okay? So now that we know one angle on one side, we could find this distance. We could also find this distance. We could also find that angle, though I don't think that's going to be helpful. But finding the distance right here will definitely be useful, right? Because then if you look at the big triangle, now I'm going to draw the big triangle. I'll draw that one over here. What do we know here? Well, we don't know this. We need to know it. We don't know this, but we need to know it. We've just said that we could figure this one out. Wouldn't that be useful to know this? That'd be useful. And it would also be useful if we could figure out this side here. And we could figure that as well. We know this is 40. If we found out this little bit here, we could add it on. So in other words, what you need to find here is you need to find both of these. You need to find this side, I'll call it M, and you need to find this side, I'll call it N. So let's zoom both. Let's start with M. If I look from 36, M is opposite, and this is hypotenuse. So that's sine. Sine 36 equals opposite M over hypotenuse 20. 1 times M is M. 20 times sine 36, and 20 times sine 36 is 11.8. Okay, now let's find N. So this time if we look from 36, it's adjacent in hypotenuse, so that's cosine. Cosine 36 equals N over 20. 1 times N is N. 20 times cosine 36. And 20 times cosine 36 is 16.2. Alright, so let's go back and see what we figured out. We have figured out that this distance from here to here, that's M, is 11.8. And you can write that right here, because that's on the same triangle, the whole big triangle, right? This is the big triangle. By the way, you know this is a right angle. And now we want to figure out this whole bottom piece. Well, we know this bit in here is 16.2. And we know this bit here is 40, so the bit down here is going to be 16.2 plus 40, which is 56.2. Great, now we're getting somewhere. Next thing you want to do is, well, you could find out x right now by doing the Pythagorean theorem, or just to show you how you don't need to use the Pythagorean theorem, let's get this angle first. So if we look at this angle, which sides do we know? We know opposite and we know adjacent. That is tan. So tan theta equals 11.8 over 56.2. Now remember, we're finding the angle. Your teacher is fit. If you're finding the angle, you need to use inverse tan. So theta equals inverse tan of 11.8 over 56.2. Use your second tan or your inverse tan or your shift tan, and you're going to get that that angle is 11.9 degrees. Now notice that's not bearing. We'll come back and talk about bearing in a second. But this angle right here is 11.9 degrees. So you could use the Pythagorean theorem, or you could now use this angle and either one of these two sides you want to get x. I'm going to use this angle, 11.9, this side to get this. So if I look from the angle, this side is 11.8, it's opposite, this is hypotenuse. So that's sine. Sine of 11.9 degrees is opposite, which is 11.8, over x. Oh, x is on the bottom, got to switch them. So x equals 11.8 over sine 11.9. And if you divide 11.8 divided by sine 11.9, you get 57.2. This distance up here is 57.2. 57.2 what? Knots. Okay, we found the distance. The boat has traveled 57.2 knots. Okay, the last thing we need to do is we figured out that this is 11.9 degrees here. We got to figure out what the bearing is. So again, draw a little northeast southwest thing right here. If this is 11.9 degrees there, how much would be left there? Well, the whole thing's 90. So this angle right here would be 90 minus 11.9, which equals 78.1 degrees. So the bearing is, it's not north. North would be directly upwards. It's this much, 78.1 degrees west of north. So your bearing is north, guess I'll do it in blue, north 78.1 degrees west. You need to go 78.1 degrees west of north, right? You're not going in that direction. You're going 78.1 degrees this way, and that's the direction that the boat was heading in, and still is heading, I suppose. And so far it's gone 57.2 knots. Very, very difficult stuff, isn't it? So work hard, do your best, and stay positive.
This is what you'll get. This is what you'll get. This is what you'll get.